Hello, everyone. The ones that are here, and I hear there are a lot of people connected via Zoom. So hello to all the sides. And my name is Staša Puškarić. I'm an oceanographer, and I teach environmental science classes at Rochester Institute of Technology. And I have a passion for building guitars. So today, after 30 years in climate business, I had some kind of thoughts, okay, what is going to happen with guitars in this warmer world? And today I just want to share some of my thoughts and my ideas about this particular issue. So on this slide, you can see these two numbers, 275 and 420. And I know that to some, these numbers don't mean much, but they actually represent concentrations of carbon dioxide in the atmosphere prior to Industrial Revolution, 275 ppms or parts per million. And these are the concentrations today, 420 parts per million. Now, again, these numbers might mean nothing. However, what is the difference? What does the difference between 275 and 420 mean? Well, the difference means more than 500 billion tons of carbon dioxide in the atmosphere, which actually should not be there. So this is on us. This is what we did in the past 200 years. Now, again, one would say, well, you know, there were eras in geological history when the concentrations were even higher. So why should we worry? Well, this is what we know. Consequence of this rapid, very fast increase in the concentrations of carbon dioxide is warming our planet dramatically. I know to us it kind of seems gradual, very slow, but compared to whatever happened in the history, changes that we're witnessing today are extremely, extremely fast. So what did we do? We disrupted the water cycles, redistribution of precipitation globally. So we know today that there were ancient civilizations like the Mayas or Angkor Wat or US Southwest, Easter Islands that collapsed only because they did not understand the functioning of water cycle. You know, this is something which is kind of weird to me because, you know, Mayas, they understood astronomy extremely well. Angkor Wat, they were amazing managers of water resources. So for instance, New York City water management system is actually copied and pasted water management systems from Angkor Wat, and yet they collapsed, they disappeared. Why? For disrupting the water cycle locally. And this is what we understand today, how that happened. And yet, in the same time, we make the same mistake. However, the difference is that we are doing it now globally, on a global scale. So it's not just the water cycle as a consequence. Today we understand the connectivity between different processes around the world. So it's about the energy that we kind of don't take into consideration, that energy flows and matter cycles. So this is something that, you know, we don't take for granted because our human system is organized in a completely different way. We cycle money and we promote one-way matter flow and not taken into consideration actually the source of the energy that we use. Even though one could say that fossil fuels, this is also sunlight, however, ancient sunlight. And when we ask ourselves, when we look at our planet as a system, as a natural system, me personally, I'm looking at the planet as a living organism because it has all the characteristics of an organism. And if we ask ourselves, how do these natural systems achieve sustainability through 3.7 billion years of time through which life exists on this planet? And the answer is very simple. Using renewable energy sources, primarily from the sun, and recycling everything. But recycling how? Because natural systems, they treat their waste on site. There is no transportation. So, we can all feel it on our skin, the intensity and occurrence of weather extremes is happening on an annual basis. This is something which most people don't even understand. What you're looking at is the distribution pattern of jet streams. So these are wind patterns which blow above the troposphere. So these are stratospheric winds. And what is important about that? Well, we disrupted that too. And the importance of the stratospheric winds is that they actually regulate the pattern of the winds in the troposphere because they're extremely fast. They're moving on the top of the troposphere, and due to the friction between these two layers, they move the air below. So I believe you can see, the Greenland and Norway and North Sea, and the patterns have this weird configuration. This happened in June last year. But, we have jet stream forecasts, so you can actually open these forecasts and find it out yourself. What is the problem here? Stratospheric winds, and our planet in normal situations has 6 convective cells of air. And these 6 convective cells of air have been disrupted. So if we look at jet streams on the top of the North Pole and the South Pole, in normal situations, they have a circular pattern. So they blow in a circular pattern, both up and down. And here we can see that something weird is happening. We have the winds from the north diverting down to the south and actually allowing the cold air from the north to protrude very far down. So as you can see, almost all the way to Africa. Now, that it corroborates the situation on land, so we have temperature measurements on land, and here you can see that the same day this cold air was coming down all the way to Portugal, and we had experienced dramatic heat wave in Croatia. But look up, all this hot air from the equator reached very far north, and this is what the problem is. So because of the warming, these stratospheric winds, they slowed down. And in these conditions, they can divert down to the south, make these tongue-looking elements, allowing the cold air from the north to go down, but in the same time, the warm air from the equator to reach far north, which further contributes to warming. And especially in these conditions, we have the thawing of the permafrost. So the tundra, so these huge areas in Russia, Canada, which acted as a large refrigerator for the past 10,000 years, So what is the issue with permafrost? So the warm periods are very short. So the plants have enough time to grow, but they don't have time to die and decompose. So when they grow, they're immediately frozen. So with this warming, these warm periods are longer and longer and longer. And the plants have the time to grow, they have the time to die, and they have the time to be decomposed, and this carbon returned back into the atmosphere. However, that's not the whole story. We have a lot of carbon stored in this refrigerator in these north parts. If we just look at the mammoth poop, so there were a lot of mammoths wandering around the tundra, and they left the poop behind, which was frozen. And now, going back several years, this storage of mammoth carbon is being released back into the atmosphere. And it was calculated that only in the mammoth poop, we have 500 billion tons of carbon waiting to be returned into the atmosphere. Now, watch this. So I said, we already have from our emissions 500 billion tons above our heads. So this is the extra carbon. And now this additional 500 billion tons is going in. So we have dramatically increasing exponential curve of concentrations of carbon dioxide and warming around the world. And the story is not finished there. Why? Because in these conditions, this is what we call ice lakes are formed. So ice serves as an insulator, and the ice starts melting from below, forming little lakes beneath the ice, which form anaerobic conditions. So decomposition in anaerobic conditions has completely different products from anaerobic. So primary product is hydrogen sulfide, the rotten egg smelling gas, which is toxic, and the second on the list, methane. So a lot of methane is being released into the atmosphere. This is a problem. Why? Because methane has a warming potential which is 25 times higher than carbon dioxide in the atmosphere. However, the residence time is shorter, so methane can stay in the atmosphere for about 10 years, and carbon dioxide more than 1,000 years. This is why we have, and why we're talking about carbon dioxide primarily. So this is what we did. And further going in the chain of reactions, a couple of years ago, the scientists working on Greenland, and I have a couple of friends working on Greenland and Antarctica, they have noticed that the ice is becoming kind of black and gray. You can see all these dark areas. And first it was thought that it's deposition of aerial particles, and most probably the particles which are trapped in the air, in the ice, and when melted, they concentrate. And then they took samples of this ice and found something extremely interesting. This is what you can see on the top picture. All these black spots, they are algae. So plants growing directly on the ice. What does that mean? That means that we have a new system which accumulates energy from the sun and contributes to faster melting of this ice. Now, how does this relate to us? Why is this important to us? Because, we can see that large areas of Greenland land-based ice are melting. So last summer, we had a daily melting of 85 billion tons of ice. So we have satellites over Greenland. We have satellites over Antarctica, trying to calculate the mass balance, so how much ice is being accumulated during winter and how much of this ice is melted during summer. Because this is one thing that is important for us, because, you know, melting of the land-based ice raises sea level. So what you can see, these are images from radars mounted on these satellites, which detect water movement beneath the ice. So mind you, we're talking here about 2 kilometers of ice, and we have rivers flowing beneath directly into the sea. So 85 billion tons of ice melted in just one single week. And of course, you know, areas like dead ice. Why do we call this area in Greenland dead ice? Because this ice hasn't moved for 10,000 years, not one single inch. Look at it now, completely broken and moving towards the sea. The same situation is happening on the western part of Antarctica, moving rivers beneath the ice, a lot of ice, weekly loss of ice measured in hundreds of billions of tons. What does this mean to us? This chunk of ice on Antarctica can raise the sea level 7 meters. The chunk of ice on Greenland can raise additional 7 meters. And when we say, well, this will not happen tomorrow, that is true. It cannot happen in one day. All this ice cannot melt in such a short period of time. However, some models have shown that we could expect a rise of sea level within the next 5 years to be several meters. So, you know, the argument is, again, that the uncertainty is still pretty high. You don't know what can happen. But this is the future that we have to foresee for all of us and the future generations. And, you know, like Antarctica, you know, these are the results from laser measurements. We know that this ice, 2 kilometers of ice, is moving up and down. So this is average 30 centimeter moving, because when you have a lot of water packing beneath the ice, it pushes the ice upwards. And then when the water comes out, then it comes down. However, this movement is detected to be up to 1.5 meters. So imagine 2 kilometers of ice going up and down 1 meter, showing us that it's pretty unstable. And the entire western part of Antarctica is sitting on a slope, and this ice can easily just glide down into the ocean. And I know, you know, this story doesn't end here. So there are these feedback mechanisms, so consequences, so one process influencing the other. So for instance, increased concentration of carbon dioxide in the atmosphere is followed by acidification. Why? Because the form of carbon dioxide in the ocean is not CO2. It's sodium bicarbonate or baking soda. So it has to pass through chemical transformation through bicarbonate ions, which release hydrogen atoms in the seawater, and this is why ocean becomes acidic. And you can see the pH going down in the same time. And one could say, well, you know, from 8.13 to 8.8, that's nothing. However, did you know that pH scale is logarithmic? So we're talking about 5% increase in the acidity, which dramatically influences. First, there are signs that all these organisms in the ocean which produce calcium carbonate shells for protection, they cannot do it anymore. So their shells are smaller and thinner and full of holes, prone for all kinds of different infections. So this carbon sink, which is dramatically decreasing. So it's not just the shells, but also phytoplanktons, coccolithophyrids, which produce and create calcium carbonate plates over their cells. They cannot do that anymore. What does this mean? That more carbon ends up in the ocean. The oceans are losing their ability to remove carbon from the atmosphere. And furthermore, we know that changes like we are witnessing today have never happened, at least in the past 25 million years. We know that from ice cores. You've heard about the ice cores that we can track down every single year, the winter and the summer. And now we have all these different technologies that we developed, so we can actually measure the temperature of the atmosphere around the Earth for the past 20 million years. And we know that the changes that we are seeing today never happened before. And of course, you know, looking at tree rings, the same thing. We can track every single year, and especially with wood. We know that these changes are happening dramatically fast. Again, coming to wood, does anyone know which wood this is? This is spruce. This is material which you make the soundboards on guitars and violins and violas and all these instruments from. And do you know this wood? No, this is cedar. Again. Now, most probably what you don't know is what actually gives the sound, what makes the wood vibrate in different ways, is the microscopic structure of this wood. So we have tiny, well, let's call it carbon nanotubes, which are filled with air. And this structure defines the frequency of a particular wood. Now, you know, I hear a lot, you know, that this guy is making a replica of Torres guitar. This guy is making a replica of Stradivarius violin or something like that. Guess what? Understanding this and understanding that changes which are happening are influencing also the changes within the structure of the wood. So we have higher temperatures, higher availability of water. Why? Because higher temperatures, we have actually more vapor in the atmosphere than we ever had before. We have disrupted water cycles, which also disrupt the nutrient cycles and availability of nutrients around the world. So, you know, you have a region, for instance, in Italy, in the Dolomites or Switzerland, and said, okay, this is where Stradivarius was using the wood from, even though that area is now protected. But guess what? The wood that he used doesn't exist anymore. So the density of the wood is changing. So for instance, you know, there is a difference between Northeastern American spruce from European spruce. So the North American spruce has much higher density, so 400 kilograms per cubic meter. European spruce, 200 to 220. So it's lighter, but it's stiffer. And this was before. What is happening now, difficult to say. But this is what we have to understand, that wood that we're using for making instruments is changing as well. Now, I always say we are weird species on this planet. We are a young species, and what people say, we received this blessing with this brain that we can understand, but refuse to use it. And my question was in this time, why aren't we using our brain to understand and accept these changes and try to adapt to these changes, rather to go against the laws of nature? And today we know, there were so many misconceptions, misconceptions not just about wood, but about us. Because, some had the arguments that how come that all these changes that make us who we are today happen in such short period of time? And we didn't have enough evidence. We didn't have enough fossilized remains of us, because we always liked to habitate near water. And in these conditions, the remains are very difficult to find. Despite that, we did find some. So this is the oldest Homo sapiens remains from Ethiopia. And it has been dated to be 195,000 years old. So the oldest human. This is the area where these remains were found. Erosion actually gives access to these fossilized remains. And this is what geologists are doing. They're going up and then dating each layer by layer. So today we know this is the oldest human there is, 195,000 years old. Now the question is, when we look at the changes from our, ancestors, archaic humans, from our, relatives like chimpanzees and gorillas, genetic changes that happened in our DNA are so dramatic that it seems totally impossible for these changes to happen in such a short period of time. So many people said that we are aliens, that the aliens came and manipulated with our DNA. Well, that is not true, because luckily for us, so this is the idea how it looked like 195,000 years ago. But then in Morocco, on the site called Jebel Irhoud, they found remains of a humanoid species dating 315,000 years old. Now, note this. You know where Ethiopia is in Africa, and Morocco is completely on the opposite side. Now, this was the first kind of wow moment for us, because this species has characteristics of both archaic human and modern human. So this is kind of strange. We have something in between the archaic and modern humans. And again, this is the site, so you have to appreciate the effort of these anthropologists. So look at the site and the excavation that had to be done slowly until they found these remains. So this is where the site is. And of course, the model how the species looked like. Now, why am I telling you this? And actually the smoking gun appeared accidentally. There was this lady in South Carolina, and she was trying to track down her ancestors. You know, she wanted to find out from which part of Africa her ancestors came. into America. And she found the oldest relative and took a swipe and gave it to this company to analyze the DNA, because so many people are doing it today. And, you know, this institute, which did the analysis, was surprised, and this was like a big bang in scientific community, because, and this chromosome that they detected, they named it A00, or Albert Perry, that's the relative that gave the sample for analysis. What does this represent? This gene is 338,000 years old. So our oldest father is 338,000 years old. However, this gene gives us another information. It gives us evidence that there was crossbreeding. So, and this was found in Western Cameroon. Again, one representation, and basically the community. So now we have an ongoing, very large scientific project. They're analyzing DNA of the entire community, because this was the first evidence of interbreeding. So there were like 16 different species of hominids living in Africa. And, you know, the idea was that, you know, we originate from Ethiopia and then we moved to Europe and Asia. Not really. There is something that happened before that. Western Cameroon, Morocco, Ethiopia, all these different groups of people, they not just communicated, they interbred. So they made babies. Isn't that cool? And we are all carrying these genes. So this is what then started this theory of hybridization. And we analyzed also, you know, other species. And the results tell us that any two species can interbreed if they have the same ancestor within 1.5 million years ago. So we have genes from Homo erectus, so Neanderthals, and Denisovans. And we inherited from them our skin, our hair, and most importantly, immunity. So we are all hybrids. There were no aliens involved in the process. We know that it's a consequence of interbreeding, so between different groups of people, which then change the characteristics of one dramatically. And this is how we became who we are, interbreeding with other species. Now, again, another misconception is about the migration from Africa. And they say that, well, you know, 200,000 years ago we started migrating into Europe. No. The first migration happened 1 million years ago. So Homo heidelbergensis, this is one species, it moved into Europe. And it actually then provided, so we had this northern branch of this species and the eastern branch. So they diversified. They created two different species, Neanderthals and Denisovans. And now the question is, how do we all carry these genes? So all the people on the planet carry Neanderthal genes in us. How did that happen? Now, before that, I have to tell you that something happened to us 75,000 years ago. On Sumatra, there is this little lake. And there has been an explosion of a supervolcano 74,000 years ago. So it's called the Toba explosion. You can Google it. But just comparison to other famous eruptions, it was a catastrophic event. So it darkened the skies around the globe for 3 months. Most of the plant species died, and our population numbered 1 million people. This is one calculation. What happened 74,000 years ago, our population, 1 million people, decreased to less than 2,000 individuals. So this is where our history begins. 74,000 years ago, we started migrating. So just that you see the caldera of this supervolcano, so the scars. And after that, our migration started. So how do we carry Neanderthal genes? We didn't exterminate them. We lived with them, and we interbred with them. Imagine that. So this was beneficial for us. Well, this is the environmental response mechanism to change, because otherwise we as a species wouldn't survive. Now, again, why is this so relevant for us? For a very simple reason. Now, all of us, 7 billion people, we have just one gene pool, one. Not 2, not 16. And we are experiencing changes around the planet. So how do we adapt to these changes? We don't have anybody to interbreed with, because we passed what is called a genetic bottleneck. So our gene pool has decreased, and it's very small. It didn't just happen to us, to tigers, to elephants, to crocodiles, but it's relevant for us today because, well, you know, how do we adapt to these rapid changes which are happening now? Because, you know, imagine that summers in Croatia turn into very hot summers, up to 50 degrees. And one would say, well, we have air conditioning systems, fine. But how will that influence you? Will you be able to adapt to these high temperatures? So we have groups of people that can resist to this temperature, but again, how? With using a lot of energy to cool ourselves down, because our temperature threshold is very narrow. 7 degrees Celsius. So we maintain with our metabolism and with the help of air conditioning systems. So how do we find a solution to that? And again, I say, you know, a couple of years ago, I was very much against genetic engineering. And now I'm not, because, you know, to be able to adapt to these changes, we will need something, to do something, to make us more resistant to these different environmental elements. This went too fast. And of course, you know, coming down to the question, what does all this have to do with guitars? Well, we found this patch of energy, and we found ways how to increase our and support the higher population size. So our population size is still exponentially increasing. And all these people around the world, they need food, they need water, basic needs, beside everything else. So we have to clear the forest. You know, when we look at Europe 1 million years ago, it was covered with a forest. Where is this forest now? Well, a large part of it here in Croatia, but we are looking at just patches of these forests which are still hanging around. And Where is this going to? More and more of forests are being transformed into arable land. So these are the images from Brazil. They're deliberately burning down tropical rainforests and transforming them into agricultural surfaces. So this is deliberate, this is not accidental. And this is how it looks from the satellite. And to pastures, I think, to pastures, because the demand for meat around the world is also dramatically increasing. So with that in mind, what did I do? I turned vegan. I don't eat meat anymore. My humble contribution to all these changes. So we are dramatically changing these natural systems which control the balance of elements and water and nutrients with dramatic, catastrophic changes. Looks like cancer. Do you know where these pictures are from? These are from Madagascar. You know, Madagascar is an interesting island. It has been isolated for about 1 million years, or several million years to some hypothesis. And most of the species on Madagascar are endemic for the entire world. And because of the actions of the government, of fulfilling some kind of ideas of increased population and wealth, this is what happens. So vast areas are deforested completely. And nobody's taking into consideration the erosion. So biodiversity falls, topsoil ends up in the ocean, influencing primary productivity, and actually the fishing in this area around Madagascar decreased 60% just because of the particles which are entering the sea. If you fly over Madagascar, this is the scenery. And this is what nobody expected because they didn't consult geologists or any experts. So we have these erosion channels, crevices, which are up to 150 meters deep. Beside that, we have illegal logging as well, because everybody said poor people, they have to feed their families. So they will go out and extract this wood and sell it on the market, even though we, as a community, global community, decided that we want to protect it and preserve it for the future generations. So this illegal logging also happens in Indonesia, in Brazil, all over the world. And this is, I think, I don't know, the image that should stay in your minds, because do you know which tree this is, you guitar players? Did you ever hear about Rio rosewood? Huh? No? Palisander Rio. Most of these very famous guitars were built from this Rio. And this is how it looks in nature. However, it was banned because it was just cut too much. And it, not just cutting, but also the sale on the global market has been banned. And what are Brazilians doing about it? Well, this is an interesting story, because it seems to me, I cannot be sure, but the locals go into the forests, they cut the wood, they prepare it for transportation, for sale. And then the government comes with guns and they confiscate all this cut wood. And then the government sells it on the market. 95% of all this wood ends in China because, there is a trend between these newly born Chinese rich people. They want to have carpets on floors covered with Rio rosewood. So there is a high demand for this product, and of course high demand among guitar makers around the world. And again, diversity falls. Now, this is an image. Unfortunately, this happened so fast. I got an email from Madinter from Spain, where I've been buying supplies from for a long time. And they say, we have Rio rosewood on this for sale. And they had 4 sets of Rio. Each set, just the wood that looks like this, 4 to 5 millimeters thick, 2,000 euros. So how come they can sell, and you can see the Madagascar rosewood as well on display here, knowing what consequences are happening in Madagascar? So we are dramatically decreasing the gene pool of all the species. We're losing 65 species per day out of 1.8 million that we know of. Are we doing anything about this? This is an image from spruce forest in Alaska. So these spruce forests are amazing. You have spruce trees which are like 50 meters high. Steinway makes pianos from this spruce. 15 million hectares of this spruce forest dies every year because of this little bug, bark beetle. So imagine 15 million hectares die every year. Why? Because the only element that controls the population size of this bark beetle is cold. And since it's not cold anymore, most of these critters, they survive the winters and their population explodes, resulting in dramatic loss in forests. So the point I'm trying to make, these bad things are happening globally. And it seems to me that nobody's taking this into consideration and trying to think about, what kind of solutions might we have? Because additionally, we have all these forest fires and everything, and we have a global disruption of the supply of nutrients. Because why is this important, for instance, for South America? So these are dust plumes. This is called Saharan dust plume. We have another Pacific dust plume, but these particles, they are picked up from the deserts of the Sahara, and they fly all over the Atlantic, are deposited in Central and South America. Without these particles, there are no tropical rainforests, because these micronutrients, there are many of them, are not naturally available in that part of our planet. So if this goes in a different direction, we will lose all the tropical rainforests. The same thing goes for the Pacific dust plume. And we know from ice records that sequence of events of warming and sequence of changes in air patterns move these particles down south. So these particles start seeding the southern oceans, and another thousands of years of changes come. This is how our planet warms up and cools down. Now, what can we do? What do I do? Because, I stopped thinking large scale. I said, okay, changes always happen from individuals. And what I'm trying to say is that we have this brain capable of understanding that, you know, natural systems, our planet thrives on diversity. So we have to be part of this, not against it. We forgot about that. And it's simple, you know, use renewable energy, recycle everything, treat everything on site, eliminate transportation. That's one thing. But what about guitars? Well, that's why I kind of changed my approach. And this is why I brought this guitar. This guitar is made from waste. So all these little parts of wood, they would normally end up in garbage or in the stove. I kept them and I built everything from waste, including the soundboard, which is made from 6 different pieces. So I buy waste wood from all these places that cut the wood. I find their waste, which would normally end up in a stove for burning, and I make a guitar. Is this an approach? I don't know. So another approach I did is, well, this is an experiment. Now I've focused my attention on building violins. They're smaller. I'll become a fiddler very soon. But I have enough material to make violins my whole life, because one deceased friend from Gorski Kotar gave me a maple tree. So I have a maple tree in my house in the attic, and so basically I don't need to build guitars, even though, as I said, you know, this is my passion. This is what I've been thinking about and dreaming about doing since I was 4 years old. Actually, I started playing the guitar and then they switched me to piano. But this stayed inside. And, well, I'm keeping busy in different ways. The other thing is, you know, why is there such a high demand for all these guitars? Why do all these different companies, they make like thousands of guitars, which are extremely cheap? And, you know, because one has to ask the question, you know, how much does an instrument really cost? Because one thing is the price of this wood on the market, but what about the price of all this destruction that happened around that tree that was cut? Who will pay for these damages, for erosion, for decreased fishing practices? We are not internalizing external costs. So if you take all that into consideration, the guitars should be much more expensive. However, taking care that part of this and that the system that we created, which has nothing to do with how nature works, we reorganize it so we preserve what is left. And the other thing is, how does nature really work? You know, the fascinating thing about species for me, and you know, in literature it is called domination exclusion principle. What does that mean? That means when we look at all the species on our planet, they avoid competition. Consequence of competition is that one must die. All the species avoid competition. They share resources. So this also contributed to evolution. This is how we have all these different birds around. So like when you look at the spruce trees in Alaska, so one spruce tree hosts 7 different species of birds, and they don't even touch each other. You know, I lived on the island of Mljet for 13 years. And when I came, I was kind of amazed that, you know, in these old houses, cockroaches are like domestic pets. You know, they run around the house. And I said, okay, let's see if this domination inclusion principle works. And I monitored the species of these cockroaches in these houses, and I found out that there is one species that runs around during the day. You cannot find it during the night. During the night, there is another species. So you have 2 different species of cockroaches sharing the same resource, avoiding even to see each other. So can't we do something like that and avoid competition and think about sharing, protecting resources? I don't know. At this particular moment, you know, there are good news. There are a lot of people, more and more people understanding, but on the other side, I'm not so sure. Because, you know, conflicts is something that we obviously need. And I can only say, well, I hope there will be a better future for all of us and that you will continue playing because, you know, what is music anyway? Did you ever think about something like that? What about all these vibrations? Why do we like some, we don't like? Because, you know, how I see it, musical instruments are actually a reflection of how matter is formed. So on the quantum level, because, you know, what we see, what we hear, it's about, you know, the energy organized in a very particular way, in very particular dimension. So I think this is something important, and this is something that we actually need. I personally believe that we all need music. With music, we become better people, not aggressive, conflict-seeking, greedy individuals. Do we deserve this planet? I'm not very optimistic anyway, but I don't give up. This is why I'm talking to students at the college every opportunity that I have, and changing myself, because this is what has to be, you know, like, I don't know, 5, 6 years ago, I would say I cannot survive without a bloody steak. I can, without any problem. So it's the will to change from inside, and this is what has to happen from each one of us internally. So we can change the world in something a little bit better. I don't want to bother you anymore. Thank you very much for your attention, to all of you here, to all of you wherever you are, and make this world a better place.